All right. All right. Well, welcome everyone. I've got 11:02. We've got a good group. So let's go ahead and jump in, get started. So again, welcome and thanks for attending today. My name is Nicole Evans. I am the Territory Sales Director here at Vast Data. I have responsibility for Kentucky, Ohio, and Indiana. So I was happy to host today as I see lots of attendees from the territory. So I thought it would be a great opportunity to have some in-territory exposure. I'm actually based here in Columbus, Ohio, so local to the territory. So backup and recovery at the speed of flash is where we're going to focus in today. So we could jump to the next slide. All right, just by way of flow and how we're gonna conduct the webinar today. I'm going to kick you off with a couple of slides, just kind of company introductory slides, and then I'm going to hand it over to Billy Crafton. Billy is our Senior Director of Systems Engineering here at Vast. Billy has responsibility for all of the SEs east of the Mississippi and up to Canada. So tremendous amount of resources on his team. Also, fun fact about Billy, he's located in Dayton, Ohio, so he is in territory as well. So we can pull him into any direct interaction, again, because he is local. And then George Axberg is going to dive us into data protection more specifically. So George comes with a tremendous amount of experience in the DP space. I'm going to talk a little bit about the industry, kind of what's going on, what we're seeing, what we're hearing, and really talk about that transition from backup conversation to a restore conversation and how that's impacting you all, and frankly, us as well as we're delivering product into the market. And then Rob Gerard is our technical specialist. He is a data protection SME. He's going to talk to you about some of the unique capabilities that we have here at Vast that makes us a superior solution for data protection strategies. So what are we all about? Our mission, our goal, what we're trying to accomplish here at Vast, very simply put, is we have driven down the cost of flash to enable enterprises like yourselves to build all flash data centers. So no longer is it necessary to own, operate, and maintain multiple point solutions in your environment, and all the cost and complexity that it takes to manage and migrate data up and down the tiers throughout the data lifecycle, right? We see that as something that's in the rear view mirror. So going forward and looking forward, we're offering a universal storage solution that, again, very, very simply put, is a single data platform for fast access to all of your data. So end of year 3 selling, we're at $300 million bookings run rate, just under 4x year-over-year growth. That has made us the fastest growing infrastructure company in history. Also very proud to be cash flow positive. We have a very strong balance sheet. We have not had to dip into any of the investment dollars that we've raised over the past several years. So very proud of that. Staying on the proud theme, we also wanted to highlight the Gartner Peer Insights survey that our customers participated in back in April. 100% of our customers surveyed said they would recommend Vast to their peers. So Gartner was blown away, certainly the first time 100% of customers have all responded accordingly. So net, we are a strong financial company and we have lots of happy customers. So with that, Billy, I'm going to turn it over to you.
So just kind of give an overview of our architecture before we turn this over to George. We designed in a solution that was meant to handle failure. We built it on Docker containers, leveraging newer technology that was available. We very much wanted to focus on performance and minimal effort whenever we were looking at our solution. So we started out with leveraging NVMe over fabrics. So all of our compute nodes will connect directly over NVMe to our disk boxes. And within those disk boxes, we leverage QLC flash for low cost. And then we leverage storage class memory for that initial NVRAM type of platform where we land the data. Next slide. So when we look at the solution, we have simple configuration where we have our compute boxes. And we can scale those out based on front-end performance requirements or pooling or any type of environment where we want to specify certain workloads for critical applications. Then we have a simple NVMe switch, which is either 1632 or 64-bit port switches with support for either Ethernet or InfiniBand. And then we have our disk boxes. And those boxes start out as either 675 terabytes raw or 1350 terabytes raw. That works out to about 550 terabytes usable before dedupe and compression, or 1.1 petabytes usable before dedupe and compression. And then we'll get a little over 40 gigabytes a second read, or 144 terabytes an hour read performance for restores or different type of workloads. And then we leverage the storage class memory for that write activities and leverage it for NVRAM versus typical DIMMs, which would require capacitors or battery backups. Next slide. So whenever you look at our environment, we are a network attached storage architecture. So we currently support NFS v3 4.1. We do support RDMA direct. So anyone who is leveraging GPUs, we have detailed white papers on that integration. We're currently finishing up our SuperPod integration and certification with NVIDIA. We support SMB 2.1 and aspects of 3, especially around performance. And then anyone leveraging S3, we have full support for S3 with lifecycle policies. And anyone leveraging Kubernetes, we do have a CSI driver to make it very easy to allocate storage. And so we would connect over the protocols. We have these stateless servers that are just running Docker containers on these compute platforms. These are pretty much just Intel-based servers, nothing really special about them. It's a 2U chassis with 4 nodes per chassis. We talk through Ethernet to the disk enclosures, and then all of that data lands on storage class memory. Initially, that was Optane drives because that was the cutting edge. As many people may have heard, Optane, Intel is discontinuing support for that, but Optane had really gotten phased out because of costs and the fact that it wasn't performing like some of the newer platforms. So a little bit older technology. And now we have multiple vendors that are doing storage class memory that's based on SLC type band. And so what we do is we leverage that storage class memory for our metadata, as well as for some of the initial landing and processing. And then we do large block writes down to the QLC drives. And what that does is it allows us to guarantee the life of those QLC drives for 10 years. And then we have one large global namespace that can scale out from simple 500 terabytes usable up to multiple petabytes. Next slide. Probably one of the key differences that you'll see on our architecture versus some of the older scale-out architectures is that we are a shared everything versus a shared nothing. Since everything is built on Docker containers, one of the key things that we wanted to do was create very linear scaling. So I can continue to add compute nodes if I need front-end bandwidth. On the back end for capacity, I'll have my D boxes. All of our traffic, unlike your typical scale-out architecture, is north-south. That means when a client connects to a compute node, that compute node knows where the data is. So if it's on one D box, it'll go ahead and pull that directly off the one D box. If we have 10, 20 D boxes for large environments, it'll go ahead and directly access those NAND over NVMe. The big difference is that if we have a failure, if you lose a node, it's all transient. The next node will pick it up. All the storage connection information is maintained on the D box. What that means is if you have older SMB or NFS clients, you don't have to go back and do a retry. All the connection strings are actually maintained and seamlessly picked up by the next container whenever it picks it up. And that just allows us to have that high availability, as you saw, 7 nines availability. Also, if we have a failure of a node, we don't have to worry about load balancing since all of the nodes talk down to the D boxes over NVMe direct. But it allows for quite a few things. It allows for very easy scaling. It allows us to have the ability to add more compute nodes versus disk boxes, or if someone needs more capacity, we'll add the disk boxes. Then we still get that global namespace and global dedupe pool so that we get very granular dedupe where we leverage similarity, which we'll talk about a little bit later. And then if we have rebuilds, we don't really have to worry about a server rebuild because all of this is built on Docker containers. Makes it very streamlined. It's what I consider the next generation, especially as we look at our Gen 3 platform with Intel iRuler drives and DPUs. Next slide.
Thank you, Billy.
There you go.
That was fantastic. Perfect. Intro into the vast technology, which is somewhat unique. And sometimes we have to discuss the technology a few times, right? Because there are so many key differentiators in our portfolio. So again, my name is George Axberg. I'm the Vice President of the Data Protection Division here at Vast Data. And I'm going to take the next 15 minutes to kind of talk a little bit about what we're seeing in the data protection market and how we're focusing our solutions here at Vast Data to address the needs and the requirements of today. So first, we need to kind of maybe start with a little bit of look in the rearview mirror of what is available typically in the data protection marketplace today. Believe it or not, tape is still used and leveraged on a daily basis. It's still about $1 billion marketplace. It's really considered one of the true air gaps from a security standpoint, but it's also the fact that it's portable and it's able to be shipped, and it's really something that's been in use for 50 years. There still is a tremendous amount of tape, but there obviously are some caveats to using tape, typically around performance, generation management. Can you really have a 10, 15-year-old tape and restore from it? Probably not. So then around 2001, a new generation of technology came to market, and that was the purpose-built backup appliance. We harken back to the days of Diligent and Cepiton and EDL and Pathlight, when these first purpose-built backup appliances were brought to market on spinning disk, meant to give you great performance, and also just to be maybe that a reliable platform on-prem in the data center to augment a tape environment. It really could not completely replace a tape environment, maybe not even for long-term retention, but to augment that environment. And that market really took off in 2009 when EMC, a company that I worked for 16 years, and Dell, acquired a company called Data Domain. Data Domain really put the purpose-built backup appliance market on the map, and there were others, HP Store once, the Veritas Net Backup appliances, and they've really run the environments for data protection for quite some time. But in 2016, you kind of hit an inflection point in the industry where one cost, the organic growth of data was just so massive, and the limited scalability of these appliances forced a lot of customers to look in other areas. And obviously then cloud and object-based platforms became avant-garde. Obviously offers a cheaper tier, somewhat elastic, but it kind of goes back to where we came from with slow performance, slow restores. And that then led us back in another direction to all flash. All flash, with a lot of competitors in the marketplace, brought an all flash performance tier. And if you go back to that first pyramid slide of Nicole, what did we end up doing? We ended up tiering data protection. I've got all flash for high performance. I've got a purpose-built backup appliance, or maybe some object or cloud, maybe some direct attached NAS, maybe it's snapshots. It added a lot of complexity to something that really should be simple and reliable, and something that we needed. And it also, showed us that there were compromises in everything in the marketplace. So in comes in Vast Data. So when our founder went and brought our product to market at that time, he was focusing on high performance computing and machine learning and AI and these really big, important use cases. But a byproduct of that was, man, this vast cluster, this vast device, this disaggregated shared everything architecture lends itself extremely well to the needs of data protection today, because restores are changing. In the past, we would typically need to restore a small data set. Somebody lost something, something was corrupted. Something maybe just needed, to do a migration from one platform to the other, and something had to be restored from the backup environment. Just simple database dumps. But they weren't at the scale as they were today. Those restores for something could definitely be handled with the platforms of the past. But today, with just typical organic growth, and then added to that, the threats of ransomware, a restore could potentially be everything, not just something, but everything. Thousands of files will be encrypted during a ransomware attack. These people are extremely clever. Your VMs and containers, you'll need to rewind those to an unaffected state. How far back does that go? Where do you find a trusted environment that you can restore from? It's all dependent on, obviously, a vaulting technology that you might use. but it also depends on your ability to restore that data to a live environment. So bandwidth, and performance becomes extremely important in today's environments. And then if we listen to some of the folks in the marketplace that are giving us advice, if we think about Gartner, it may be necessary to restore almost the entire environment, hundreds or even thousands of terabytes of data. And if we think about Forrester, much less validating, they have the ability to recover potentially hundreds of systems at the same time. That's basically telling us, are we really following through with our DR plans? Can we validate the data is correct? And then once we do so, can we really recover? And if we look at the average time to recovery, 21 days by the Coveware survey, how many millions of dollars could you potentially lose in 21 days? Will you be in business in 21 days? That's the average. Are you beyond the average? And has your DR testing shown you that you can restore your business back to a steady state after an event such as an encrypted cyber event? And let's face it, insurance companies won't pay ransoms because these are considered acts of war. So putting in a solution that satisfies those requirements are of uber importance today. So with vast data, we really want you to rethink what you've known in the past about a data protection environment. We'd like you to rethink recovery, rethink it from a positive standpoint. A vast cluster, similarly sized to a purpose-built backup appliance, is 15 times faster on recoveries. Let that sink in for a second. 50 times faster. Do you want to recover in 1 hour or 50 hours, 1 week or 50 weeks, 1 month or 50 months, meaning out of business? Obviously, network topology matters. Obviously, the data movers matter. Obviously, do you have a place to put the data matters, but we have eliminated the backup target as being the bottleneck in that DR plan with vast data as your purpose, your data protection, all flash target. Scalability is of just as much importance as performance. And we scale out versus up and hundreds of times more scalable. Billy mentioned it. We could just add our D boxes as needed to add scalability. It's all one single namespace. We have clients with 100, 150 petabytes in a single cluster, by the way, being managed by half a full-time employee, and giving that scalability. And when you add that much scalability, and Rob will talk about this a little bit later, it adds in a single deduplication pool. So you're getting a tremendous TCO. The ownership of this platform is far less expensive, not just due to the granularity of our data reduction, but just the fact that you'll need less because I'm able to have one cluster as opposed to multiple silos. We also want you to rethink resiliency. Billy mentioned it. If this truly is a backup and recovery environment, your last line of defense in the event of a hack or a major weather interruption to an environment, you need to know that the data is there. And last but not least, you need to know that that data is secure. And we can accomplish that with our indestructible snapshot. So real simple picture of what a vast environment looks like. So first and foremost, we work with all data movers within, I'm sorry, I went a little bit too quick there. We work with all data movers in the marketplace today. So regardless of what you have from a legacy standpoint, Billy mentioned it, right? Multiple protocols available to the client today. We have the ability to work with multiple data movers in the same cluster. In many instances, many at one time, leveraging multiple protocols. We also have the ability to back up and recover in a mainframe environment with third-party solutions such as Model 9 and Luminex. So again, thinking about VAST as that universal storage for multiple use cases. So the best way I like to describe it to folks is if you go to the Gartner Magic Quadrant, you look in the upper right-hand corner, every player there we work with and have interoperability testing and work done and can provide faster backup and restore than anyone else on the planet. If you think of some of the fringe players in the Gartner Magic Quadrant, we still work with them as well, right? So everyone on this webcast today can participate in the value that vast data brings. Now, again, we really like to focus on the ultra-fast restore. It's important to us. We also like to focus on our file reduction capabilities. 3 levels of file reduction capabilities. I'm going to not steal Rob's thunder, but basically we are more granular than anything else on the planet. And even in a more unique fashion, we can take already compressed and deduplicated data from any of these data movers and reduce it even further. That's very unique in the marketplace today. Most target devices want the compression and deduplication from the source to be disabled so that they can provide a better deduplication ratio on their side, obviously driven from a TCO perspective. We want that enabled and we want that turned on. And last but not least, on the bottom of this slide, you obviously see cyber resiliency with indestructible snapshots and replication. That is requirement. That's a requirement. Those are table stakes. This is necessary for today. And we believe with our new vast AirLock technology, we offer what our customers and clients are needing today on a regular basis. And last, before I turn this to Rob, and I think this is pretty important, Billy touched on it briefly. We have the ability to eliminate the need for monolithic expansions. We all know with an array, we are not an array. We all know with purpose-built backup appliances, we are not a purpose-built backup appliance. We sell a very scalable, disaggregated, vast cluster. We separate performance from capacity. You buy exactly what you need when you need it, and gives us a great ability then to just to deploy. And then as time goes on and you need either more performance or capacity, and let's say there's a next generation of technology in the system, well, guess what? We are backwards and forwards compatible. You can go out, Billy mentioned 10 years. It's an infinite life cycle. 10 years is a logical term that people maybe like to work in, but think about it. Today, you're depreciating assets in 3 + 1 + 1 or 4 years or 5 years. What if you could depreciate assets as long as Billy said, say to 10 years? Because it's backwards and forwards compatible. We're eliminating forklift upgrades. We're eliminating that forced maintenance renewal. Hey, the maintenance is more expensive than buying the hardware. We need to move forward with a refresh. We at Vast Data have changed the game on that. And the idea is that you would have an infinite life cycle in all of your clusters. So just a quick point of comparison. I picked the Dell Data Domain 9900 because it is the largest purpose-built backup appliance and the most high performant on the planet today. So all these statistics that we've been throwing around, everything we've been discussing, you need kind of a point of comparison to really understand the impact of some of these things. So if we look at a 9900, which is about 2 petabytes raw and about 1.5 petabytes usable, right? Before data reduction, gives you 41 terabytes an hour backup performance. Pretty good, sounds pretty gaudy for most environments. But look at that restore performance at only 8 terabytes an hour. If you notice, I put a double asterisk next to that number because Dell does not publish restore performance because there's so many factors that goes into the way a purpose-built backup appliance writes data, reads data, doing garbage collection and reconstitution of deduplicated data all simultaneously at the same time will affect performance. And then you see the physical 42 rack units and the power. But conversely to that, if we look at VAST, now this is a little bit of a flawed comparison. And why is I made a capacity comparison to get as close as I could to the 9900, but we at Vast Data guarantee in a like-for-like environment, we will get better data reduction. So you will not need the same amount of capacity in a vast cluster that you would need in a data domain box. By the way, same for, HP Store One, same for NetBack appliances. By the way, same for if we're just competing against traditional vanilla disk, whether it be all flash or hybrid. In a like-for-like environment, we will guarantee a better data reduction than all competitors on the planet for backup and archive environments. So even if I do a 2 petabyte environment, I still get a better usable. We don't have time to go into this today, but we have the algorithms and the way that we write data to a vast system is so much further advanced than what's available today. We give you a better usable capacity. And as the system grows, that actually increases, right? The amount of well, I like to say your capacity that we need to run our system and security against is greatly reduced the larger the system grows. But look at the performance. All right, I had to size it again for the capacity, but my performance is actually better at 54 terabytes an hour, but stop. This is where that 50 times more restore performance comes into play. I have 432 terabytes an hour on a restore, 8x what I am on a write. That flips the script, where the old appliances are typically around 20-25% at best of read performance versus write. We flip the script. We're 8 times more performant. And when you do that math, that's when you come up with 50 times. Listen, people, if it was just 10 times, 5 times, does that the difference in the event of a cyber attack, of you restoring your business to a steady state and restoring what you need to run your business and get back on your feet again? I think that matters greatly. Again, I said it earlier, network topology matters, the amount of data movers matters, physical or virtual, and you have a place to put 432 terabytes an hour. That all matters. That's part of an entire DR plan, but we've eliminated ourselves from the bottleneck in the environment. Clearly less rack space with only 14 rack units. This matters today. Less than half the power consumption. This matters today. All of these things add up to a greater TCO. And again, what I'm showing there does not accommodate the better data reduction that you'll see with our system. And then my last slide, again, this I think is a pretty good impact here in closing before I hand it over to my friend Rob, is the architectural constraints of legacy, shared nothing architectures in data domain engines and capacity, or if in an array, right, the controllers and capacity. When you need more capacity with these devices, assuming of course the box is full, you can add shelf upgrades and drives of course, but once you've maxed that box out, you need to buy another. Well, like Billy mentioned, with VAST, all we need to do is add another D box, because maybe you don't need it. You don't need the performance, you just need capacity. But then conversely, at a later date, if you need some more performance, again, you're maxed out on your box, maybe that 8 terabytes an hour times 2, 16 terabytes an hour is not good enough. Well, you have to buy another. Well, for VAST, for us, it would only be adding a C box. And then what happens when you have this scaling with just adding multiple devices? They're all individual deduplication pools. I have one universal pool in my cluster. That's going to add to cost. It's going to add to capacity. It's going to add to space, power, cooling, complexity, because it's really hard to do data classification within data protection environment, as we all know. So all of these things add to the value and the differentiations of VAST as a data protection target. So with that, I'm going to turn it over to Rob Gerard.
Thanks, George. So George made some pretty bold claims around the data reduction. And what I want to do is go in a little bit deeper on the technology that allows for that. So what we've got here is the 3 forms of reduction that we have in a VAST system. We have the first is compression. Now, this is not in the order that are applied in the system, but these are the 3 that are in the system. So the first is compression. And if we can just click it, thank you. What that does is per file in a very fine-grained but local way will reduce that data. Now, in a larger way on the global side, deduplication, especially on backups, is very important because we have an opportunity for a lot of light data. And with deduplication, what we need are blocks of a certain size to match exactly in order to dedupe them. And what do we mean by dedupe? What we're doing is and we didn't invent dedupe, far from it. It's been around a long time. It is storing a library of these blocks, and once it's seen a block, it stores it. And then when another one comes in that it recognizes, says, hey, I already have a copy of that. Instead of writing the data, I'll make a reference pointer to come back to that, that first block. Now, VAST takes it even further on the deduplication side by doing what we have is called adaptive chunking. This is a way of, instead of cutting the data into arbitrary offsets of like 32K, 4K, 8K, 64K, or some combination, we cut it into blocks somewhere between 60 and 64K, and we don't just arbitrarily cut it on offset. We're cutting it based on some signatures we're looking for in the data itself. And by doing that, we greatly increase the chance of getting dedupe on it. Now, the next one is VAST similarity. So failing compression and deduplication, we have a proprietary algorithm that goes even further. So leveraging the fact that we can address at the byte level down in the flash, we are essentially making that library of reference blocks much smaller, much more granular. So it's almost like a cookbook of recipes. So when we see partial matches inside of a block, we can now store those ingredients and reassemble it in the first place. So we can store less each time and find matches where any traditional dedupe would not find it. So with all of those together, we'll go next slide. If that isn't already a fantastic way to reduce the amount of logical data to where it's being stored. Oh, actually, yeah, before the next slide, some of the examples that we get from this similarity, and this 3-to-1 you see for like pre-reduced backups, this is assuming that you've turned on the deduping compression stuff in the backup software. And this is just that first set. Once there's a lot of times where you'll have another set over and over and over, not just for fulls, but there's reasons why you may have more fulls. So that number goes way up once you start adding more. But this is just referring to that kind of that base landing. And then in the other use cases at Vast, what we're seeing out in the field and stuff are some of these reductions that you see at the bottom of the screen. And some of these are areas where people typically don't see it being any more reducible, yet we are finding that we are reducing it more than the applications and stuff have already reduced it. Now, in terms of how we're leveraging this flash, because something that comes up all the time is, when we're saying that you can have all flash for the cost that is cheaper than disk, we don't need just that data reduction. We are leveraging QLC drives, so they're very dense, and they do have. If your system's not designed for them, and Vast is the first to put QLC drives in since 2019, if they're not designed for it, you can easily burn them out. And so what we've done is we have come up with a way with leveraging our storage class memory to make sure that we're not burning them out. And then if anybody's skeptical and doesn't believe it, we'll just throw our 10-year warranty behind that with longevity, so that if they do burn out, it's on us, Vast, to go and make that right and replace them. Now, okay, so now we've got cheaper media, and we've come up with a way to use it. We're now, we also use it very, very efficiently. So in our smallest cluster size, which we refer to as a 1x1, which is 1 C box, 1 D box, we have a stripe set that is a very wide stripe of 36 plus 4. And that is our smallest stripe. It only gets better from there. And that's about a 15% overhead. If you compare that to a shared nothing system with nodes that have to hold replication of data, automatically out of the gate, you're storing 2 copies. So you're using more than double the media just to store something. And what we're saying is we've only got that 15% overhead. But as the cluster scales and gets larger, our stripes get bigger as well. And our stripes grow up to 146 plus 4, which is a 2.7% overhead. So that's 146 data, and then 4 for the parity. And with that erasure coding, what that lets us do is a failure in place scenario where if you can lose up to 4 drives. But once you lose a drive, the system automatically starts rebuilding very efficiently by only having to read about 25% of that data from the surviving disks to rebuild on the surviving disks. And then you're back up to being able to lose 4 again. And then once that disk is replaced, at that point, your capacity kind of goes back up. So, and then with all of the data reduction on that, on top of all of this, this is how we're able to do what we're doing. Next slide. Okay, so here are some example numbers. These are going to vary based on your data sets. But here's some backup sets here, where we've got like a VMware backup, some unstructured data backups. This is what your data mover, your backup software is getting it down to through its compression and dedupe. And then Vast is just this little layer on top of it. And then you multiply those together and you get a great total data reduction. And when you get numbers like this, you can pack that much more into the system, which helps that TCO. Next slide, yeah. Now, we made also some pretty bold claims around some of those restore speeds, and that is backed by science. So the science we've got here is just the physics of a hard drive. So if you take a hard drive and you are, the finer grained dedupe you do with smaller blocks, the more reducibility you can get. However, that leads to fragmentation type issues, and it really turns into a random workload. And hard disks are not very good at random. They're great at sequential, which is why those backup speeds are for ingest are quite good on them, because they can write and keep that head in place. But when it comes to retrieving them, it's now got to pick and choose from all over the place. And if you picture a hard drive, kind of like a record player with a needle on top, it's bouncing all over the place and it takes a long time. So when we're restoring random at little 8K blocks, those reads, we're only getting about 800 kilobytes per second here, which is really small. Now, if the block size is bigger, then we get more performance, 1.6 megabytes per second per hard drive. And yes, there's lots of hard drives, but that's a pretty small number when you have many terabytes or even petabytes to recover. And then if you take that speed on an SSD, it's not even close to the same ballpark. So even if it's like, hey, Rob, we're not at 16K, we're at 128K. You have to do a lot of doublings before you're going to get up to 900 megabytes per second, pure SSD. And we've got 44 SSDs in the smallest system, and just keep adding that number. So with that many SSDs, it's kind of tough not to get that performance. So this is where we do excel, and the disk struggles a bit. Now, on the ransomware topic, if you're storing all of your data somewhere, the bad actors are targeting backups specifically, because if you're going to ransom somebody and they can just turn around and restore what you said you had from them, there's no way they're going to pay that ransom. So for these bad actors to increase return on their effort, they want to wipe out your backups in many ways. So VAST's got some features to prevent that. I've listed a number of things on this slide here. A few of the things I want to point out are around the encryption. The encryption is not a anti-ransomware feature, but it is something that prevents somebody from going and stealing these boxes and being able to get into it. This is the data at rest, and it also means that data at rest on VAST means that you don't have to do it in your data movers, and gives us the opportunity to reduce it that much more. We can snapshot all the stuff that's sitting in VAST, which can include all of your infrastructure for those backups. So like the VMs that are running the backup software, whether it's like Commvault or Veeam or Veritas, can be sitting in data stores that are sitting in VAST and can be snapshotted at the same time as those big data sets behind it. So if we're doing a plan B, plan C type of recovery scenario, we can get that. And I just want to, if we go next slide, I want to touch a little bit more on those indestructible snapshots. So in some ways, it's kind of like Worm with a twist, where snapshots by nature are immutable, and we're making them indestructible. So even if someone thought, hey, you know what, I'm going to infect the environment and then go pay off the backup operator to turn a blind eye so that, hey, if you could just get rid of those snapshots, I'd appreciate it. Our indestructible snapshots prevent not only bad actors from doing it, but also employees that you might get a rogue admin or something like that. And so this is a way that they can't do it. But not only can they not delete those snapshots, but the policy that was set around it is also indestructible. Now, there are times where maybe somebody sets a policy or captured something in a snapshot that is maybe hurting them from a capacity standpoint, and they want that gone, or they want to change that policy. We do provide a way out of it. It's sort of like a four hands approach, where two from the customer side come together, generate a key, and VAST support, and two from the VAST side will come use that key and then provide a way to modify those settings or delete those snapshots and override that retention setting. Next slide. Now, I want to introduce a feature, and when I say introduce, this is probably new for all of you. If you were on our call a week or two ago, we had actually premiered this to the world, mentioning it for the first time, which is the concept of a VAST AirLock. Now, there's a lot of virtual air gapping technologies there that say, like, hey, we will not have any ports open, it won't be on the network, and then something internally will initialize that. The airlock concept means that even when that's initialized, you never have a path all the way across. So what we have here in this top slide on the source site, we have that group of C nodes, and then you can imagine the D boxes as being the shelves that are all the data for that. Essentially what we're doing is we're disconnecting those. It's now standalone, and then we're turning on the ones that are on the other side of an internal protected network that can now read it into a clean room. So this slide here shows a scenario where we might be doing that and then sending it off to another site, but we can also do that in the same site where we're leaving it on, and then we have an air-gapped clean room. That this is kind of like taking those tapes out and then bringing them into a tape drive that's ready to go. Now that, and so if we go to the next slide here, I can show that a little easier. What we've got are a set of front-end C nodes, and some of them are running, most of them are running on that production side. And this is where all those active connections are. This is where your backups are coming into. Everything's fine, everything's good. And in that clean room, that is sitting offline. It's not powered on. There's no way to tunnel into it or anything like that. And it is kind of sitting there ready to go. Now, if we click through, next slide. Now, if we're compromised over on the production side, what we can do is, go back one. There we go. If we're compromised here, what we can do is we can now treat all of that network as hostile. And now next slide. And so we can shut it down and bring up the other side. And on the other side here, we have access to all of that data. We can access all of those snapshots that were made, all the live stuff. And from here, we can pull things out and restore in a safe, clean room manner. Next slide. Oh, you're muted, George. And it's over to you. Thank you, everyone.
I was just talking to myself on mute. So Rob, that was fantastic. Obviously a lot of data there, very difficult to get into in 15 minutes. And obviously our hope for all of the folks listening or viewing today is that maybe we could go to that next step, that next mile, and maybe have a more detailed conversation with someone from our data protection specialist team. But thank you, Rob. That was very informative and obviously in many cases very unique. So in conclusion, around data protection, again, we want you to rethink the architecture. Until now, all flash at Disk Economics was really thought to be not possible, right? You were mixing and matching and tiering with flash to purpose-built, to object, and/or cloud, and maybe even tape. And now we have a platform that really blurs the line between backup and archive and could be an end-to-end solution for all of your data protection needs. And obviously with tremendous resiliency and scale. As from a consumption model standpoint, again, we've disaggregated hardware and software. It makes it easy and prescribed that you would buy exactly for the need. You would not have to buy a model number and grow into it. You're buying exactly what the need is, and it could be as on a quarter by quarter basis, enable more licensing and more capacity to run your vast system. Again, we say 10-year hardware lifespan here. I don't like that statement. It's an infinite lifespan, again, because of our forwards and backwards compatibility, and that we warranty all parts under a service contract. Can you imagine that we would actually replace a 10-year-old drive with a new drive? I mean, that's really pretty amazing and pretty game-changing in the marketplace today. Our support is differentiating. We didn't really have time to talk about that today, but just know all of our customers get a level 3 resource. There really is no 1-800-VAST support. What's your account number? Tell me your problem. Walk me through it. We give customers direct access to a level 3 resource. We call them a co-pilot. You have access to them via text, via Slack, via email, via mobile phone. They're available to you 24/7. Obviously, they take vacations, and there's obviously a cascading plan for that. So you're always have a co-pilot at your side. And last but not least, and hopefully, again, if we have a chance to engage, we have a pretty rigorous discovery model where we want to really prove to you our solution in your environment, but we most importantly want to prove it through the proper financial modeling to make everything we talked about today believable. So thank you so much for your time today on behalf of myself, Billy, and Rob. Let me turn it back over to Nicole.
Awesome. Hey guys, great content today. Really appreciate the presentation. So we're entering the home stretch here. This is a live webinar. So if you have questions, please jot them into the Q&A section at the on your screen. But just as we're waiting for some questions to pop in, I did want to kind of reintroduce some of the resources that we have here at VAST. Obviously, you've met myself and Billy. I did see a couple of partners join, so wanted to give a call out to Nick Gardino. Nick is our channel sales manager for the territory. If you don't know Nick, hopefully we can get you engaged. And then Jake Locangelo, Jake supports my team from an outreach perspective. So he is responsible for getting the VAST data message out and exposed in the territory. So if you haven't met Jake or you don't know him, I'm sure that you will soon. And then we have multiple other resources to bring to the table as well. We have an office of the CTO that will come and talk about maybe a little bit deeper dive, as George said, into the infrastructure. We've got support teams that'll come out and speak with you about the support experience. But my favorite actually is our customers. The one thing I love about being here and working here at VAST is our customers love to talk about their experience with us. So we've got multiple customers that have written success stories. They've recorded videos. They've done, all kinds of things. There'll be, a personal reference to, just have a one-on-one conversation as well. So encourage you guys to use those resources. So again, we'll move on to Q&A. While I have your attention, though, I do want to mention that you're going to get a survey from us. We really appreciate your participation in that. Really helps us kind of gauge the productivity of the session. We'll come back to that in a minute. Let me see if we've got questions here. Just move right into Q&A. Okay. All right. Couple good questions here. So we'll just start at the top. So first question is, my backup software has data reduction. Is it really that important for the storage to reduce as well?
If it's okay with you guys, I'd love to take that one. I would say absolutely. There's a lot of things that you can do on your backup software where it will have to create a whole other set. And so just one example of that is if you change a parameter around the block size that it's being deduped to, the reason you may change that block size is for performance reasons. VAST has its own recommendations of block sizes to set at. Other vendors have recommendations. There's defaults. Defaults change all the time. Anytime this changes, any of those new block sizes have new hashes and basically need a full 100% backup to take advantage of that change. So so this is a place where the backup server is designed to do, but this is a case where the reference blocks are all going to be completely different because that has changed. So that's just one example. Another one might be if you're moving between backup vendors. Of course, one backup vendor isn't going to read the formats of the others and reduce to that. So storing those in the same VAST system means that you're storing the same, more or less the same data twice, even though they're different formats. And we can reduce that as well. So this takes the pain out of moving between vendors if you need to. And there's a ton of other scenarios, but I'll leave you with those two alone for a good reason that the reduction in the backup software alone is simply not enough.
Good. Excellent. Thanks, Rob. All right, next question is, what are some ways I can test my solution to know if I'm prepared for an attack? Rob, is that you again?
I'm happy to answer it. Sure. So one of the cool things about VAST is because we were designed for production loads before these data protection use cases, came into fruition. We are on the vSphere HCL, for example, hardware compatibility list as a valid data store, so an NFS data store. So a lot of backup software has methods of instant recovery Those only work if your backend storage can serve it up fast enough. So that's part of it to test more often. Another part to test often is to do restores. And most people don't have their entire environment sitting around in spare just for you to test and do, a restore. On Vast, you can restore it into that same location as a data store that, from a backup perspective, it just sees another logical data store out there on the network and can restore those VMs to it. And then there's plenty of horsepower in the system to run those. And capacity-wise, that data is already in the box in one form or another. And our advanced techniques mean that that's not a 100% copy. It may not be completely free at 100% data, but it can be very close in a lot of the tests I've done. And so this is a way that we can leverage that to do more than that. So if you want to make sure you're tested and set, that's one example of a way you can do that.
Perfect. All right, moving on to the next question. I think we actually just have time for this one more. Question is, if I have a disaster recovery plan, will I be able to recover from ransomware?
Planning's great. If you've thought out everything, maybe. But wouldn't it be nice to have a whole bunch of versatility and insurance policies underneath that? So having a plan, plan B is great, but plan C and D even is great. So some of our immutable snapshots and stuff like that can provide yet another layer that bad actors on the surface don't even really know is there to attack and that exists.
I would
we're at time,
also, I would also add, as we kind of mentioned earlier, VAST being part of that disaster recovery plan. I think that's kind of what Rob's alluding to. So this is why we directly contacted all the data movers. It would be easy just for us to say, yeah, sure, just connect to us via S3 and move on. But no, we're going through a lot of interoperability testing with these partners to make sure and validating that we are providing, as part of that DR plan, a comprehensive solution. So again, whether it's a Commvault, a Veeam, a Veritas, right? They're obviously going to be part of that DR plan as well. And working in the confines of that partnership, yes, could you restore? Of course, but there's obviously a lot of things that need to be done in preparation for that. We've only touched on a few today, and that's why I would encourage you, when you do that survey that Nicole had mentioned, one of the questions will be, a request for a follow-up meeting. So we'd be more than happy to dive in with you even further. And if there's a specific data mover you want us to participate together with, happy to do that as well.
Perfect. Thanks, guys. That's all we have prepared today. Like I mentioned, we are going to send a survey. You will be, upon your participation, you will be entered into a raffle to win a $50 gift card. So a little bit of bribery to get you to give us some feedback is great. Is there a question in the chat, maybe, Boone? I want to miss that one.
One more did just come in asking whether or not VAST offers an expert team that can assist in the event of, if someone does suffer from a successful ransomware attack. And I think the short answer is we are standing behind our customers and partners to help any way we can. So we've got lots of expertise on board, and we'd be willing to roll up our sleeves and help with guidance and pretty much any way that we can help. We really care about your success and making sure you can get your business back up and running. So,
and Matt, if you need a more detailed response to that, if you could reach out to Nicole, and we can certainly have a follow-up conversation. That sounds like something that needs a little bit more than a two-sentence answer. It sounds like we need to have a conversation there.
Good. All right, guys, that's all we had today. Really appreciate your time and hanging in with us. We look forward to engaging and interacting on the follow-ups. So that's all we had. And again, have a great afternoon, everyone.